Okay, welcome to this video for Material Science 410. We'll be looking at some of the impact of producing concrete and the environmental concerns. Okay, so short little video on those. So concrete, as you know, remains one of the major building materials of today and has been for a long time. Data from 2010 is shown below, where we see that in 2010 there was 3,300 billion tons produced, and this is threefold by weight to any other material that was produced that year. So clearly a very dominant material and remains so even today. Below is a time chart plotting the global fossil energy production, and we see this plotted here from 1900 to about the current area of almost 2020, and you can see a bit of a almost exponential increase there over time. The cement production follows a very similar trend. So as modern day life has demanded more construction and with modernization and larger demands on construction, we see here that the production of cement has kept up with the sort of energy production trend here. Topping upwards of about 4,000 megatons per year globally. The global cement production in 2014, as a snapshot here, broken apart by country, is broken away in this pie chart, and you can see here that China remains a dominant producer of concrete, whereas the USA is quite small comparatively there at about 1.9% relative to 56.5%. Other sort of dominant forces are sort of general Asia as well as India, with the Americas excluding the USA being dominant as well. Some of the environmental concerns associated with producing concrete are associated with the enormous CO2 footprint that is had by producing this material. So cement production has two main sources of CO2. First, in trying to produce calcium hydroxide by heating calcium carbonate, we drive off CO2 as part of that reaction to form the calcium oxide needed as the starting material for cement. This accounts for 50% of the CO2 produced is part of the footprint for concrete. Secondly, the energy for heating and grinding all of these starting materials, including calcium hydroxide, into the ultimate Portland cement, as an example, account for 40% of the additional CO2 there. So simply the energy for processing and heating and grinding is the other amount. So CO2 production accounts globally for about 5 to 7% of all the CO2 emissions. So a fairly significant factor if one is trying to manage CO2 in the atmosphere. So some of the additional kind of concerns are the environmental health and safety factors here. So there can be a lot of surface runoff from handling concretes, and this also can lead to urban heat islands, given the insulating capabilities of concrete. Particulates can lead to silicosis of the lung, and the sort of early stages of concrete are quite alkaline. We saw that calcium hydroxide base in the cure video that preceded this one. And so there's a need to be cautious in handling wet concrete given its alkalinity. And so wearing proper PPE is an important step in that regard. Some of the new approaches to address the sustainability of the materials are to apply new materials to help offset some of the amount of CO2 needed there. So adding shape memory alloys and even self-healing materials can help allow us to sort of reuse concrete. We can embed sensors so that we can detect corrosion and repair existing concrete structures rather than replacing them. And looking to apply things called eco-cement, where we can add magnesium oxide to allow the cement to actually sequester CO2 instead of making it more having it remain an inert material. And considering greener cements, where we've incorporated recycled materials, including options for fly ash there, as we saw, which was a source for the iron oxide for the illuminates mentioned earlier. So these are some, just touching on some of the environmental concerns mentioned, and some of the videos that we post to Canvas to complement this will elaborate on these kind of new approaches to address these concerns.